We're talking about graphing polynomial functions and end behavior, and we want to graph polynomial functions using tables and end behavior. End behavior is the behavior of the graph as x approaches positive infinity and negative infinity. So here we have a couple examples. Here we have a leading coefficient that is positive and the degree is odd. And so we'll talk about that. We're talking about graphing polynomial functions and end behavior, and we want to graph polynomial functions using tables and end behavior. And so end behavior is the behavior of the graph as x approaches positive infinity and negative infinity. And so there's a few things that we have to pay attention to. We have to pay attention to the degree of the function. So the highest degree, is it odd or is it even? And we have to pay attention to the leading coefficient because that's going to dictate a lot for us. So one thing that we need to remember is we need to remember our slope monster. That can help us out quite a bit. So our slope monster, if we remember, we have our eyes, our nose, and our mouth. And if we remember, positive is increasing from left to right, so this is going to be a positive slope. Negative is decreasing from left to right, so just the negative sign there. The nose is undefined. If it's straight up and down and then straight across, we have a slope of 0. The two that we want to pay attention to is we want to pay attention to negative and positive. So if it's positive, so like our eye here is positive where it starts low and works high. If it's positive, it's going to start low, start in this low side, and it's going to work its way up. So that's going to be a positive slope. If it's negative for odd degree functions, if it's negative, well, look at our negative slope here. We're starting high and going down. Here we're starting high and we're working our way down. So that's one way that we can remember which way our graph is supposed to go if we draw our slope monster. One other thing that we want to talk about is kind of related to things that we know. And one thing that I know is back in the day I used to watch wrestling, and there were these characters called the bushwhackers, and they always walked around with their arms pointing in opposite directions. So if one arm was up like this, the other arm was down like that. And so they remind me of an odd function. So in this case, this would be a negative because, right, we're starting high and going low. So this would be a negative lead coefficient. And if it was switched the other way, so they started low and worked high, that would be a positive. Another thing that we think about, especially here, is we think of a Fort Mill yes. So at some pep assemblies and things like that, pep rallies, we have, so this top example was the bushwhackers. And you can Google it. And this bottom example is going to be, actually I'll just do it over here. This is going to be the Fort Mill reference. So if we think about when we hear the Fort Mill yes, we can think of that as a positive even degree function. So when we're at the pep rally and it's time to do the Fort Mill yes, So we're going to say yes, and we're going to do that a few times, right? We're going to point our hands to the sky like this. So both of our end behaviors, we're pointing to the sky, and that would be an example of a positive even degree function. Now, I don't know that this exists for sure, but if there were an opposite to the Fort Mill yes, I guess it would be the Fort Mill no. So in that case, we would still, be our person. But in this case, we're doing the Fort Mill no. In my mind, I guess we would point to the ground, and that would be an even negative lead coefficient. So we have the Fort Mill reference is the even function. If it was a no, 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 that's end behaviors all pointing down. If it's yes, 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 end behaviors all pointing up. So here are the even functions down here. These would be the Fort Mill examples. Here's the positive. This one's the yes. We have both end behaviors pointing up. And here's the negative no, no, no. Both end behaviors are pointing down. That's for even degree. So x squared, x to the fourth, x to the sixth, anything that has an even degree. Here we have odd degree, so that's first, third, fifth. We have negative example would be over here if we start high and go low. And then we have the positive example right there. And we can always relate it back to our slope monster to kind of remember, I should start, negative, I should start up here. Oh, this one's positive lead coefficient. I need to start down here. The other thing that we need to think about when we're talking about end behavior is as the function approaches infinity, or as x approaches infinity, what does the function do? Okay. So if we're looking at the odd positive, so as x goes to infinity, what does the function do? In this case, when we're talking about the function, we say the function is f of x goes to what? So as x goes to positive infinity, what does the function do? The function goes up. So the function also goes to positive infinity. And if we're looking at the other side, so this is as x goes to positive infinity. So now we're thinking of as x goes to negative infinity. So as x goes to negative infinity, what does the function do? Well, the function in this case also goes to negative infinity. So f of x goes to negative infinity. So that's what the end behavior, that's what we need to be thinking about. And that's the same thing over here. So as x goes to negative infinity, what does the function do? The function goes to positive infinity. So the function goes to positive infinity. As we look at this example here, we have x goes to positive infinity. So as x goes to positive infinity, what's the function do? In this case, the function goes to negative infinity. So for odd functions, they're always going opposite. So if one way goes to negative infinity, the other way goes to positive infinity, and it switches for what the function is doing. For the even functions, even degree, they always go the same way. So in this case, we're looking over here, and we have the example where the function's going to negative infinity here, or excuse me, x is going to negative infinity here. So as x goes to negative infinity, what's the function do? In this case, the function goes to positive infinity. Now over here, as x goes to positive infinity, what's the function do? The function also goes to positive infinity. So in this case, whenever we have an even function, highest degree like 2, 4, 6, the function always points the same direction. Now here we have another example where we have x goes to negative infinity. So as x goes to negative infinity, what's the function do? Well, as x goes this way, the function goes that way. So the function also goes to negative infinity. Here, as the function goes to positive infinity, so as x goes to positive infinity, what does the function do? The function goes to negative infinity.